Hey everyone, we're with Border States. Our capstone project was the geoanalysis map. I'm Christian Ames.
Austin Tadman.
Yichen Li.
Jesse Knowlton.
So our company is Border State Electrics, and our sponsor is Alex Brook. Okay, today we're going to introduce company overviews, problem, solution, schedule, progress, product demo, issues, post-mortem summary, and next step. So for company overview, Border State provides supply chain solution for several diverse industries. This is an employee-owned company, and there are 110 branches in 20 states. So with a rapidly expanding, there is a problem they need to fix. They need to know where to open the new branches, and it's geographically proximate in relation to customers. They have the data, they just need to show it on the map. And so we have the following solutions. First, we build spatial analyze application on SAP cloud platform, and then we store branches and customers' data in SAP HANA, and then we use Here Map API to visualize geo content data.
Okay, and there's a couple different ways that this solution will be able to help border states. First, it'll strategically locate a new branch, so they can figure out if there's any gaps in any branch services. The second one being be able to determine if a potential acquisition is a good fit for them geographically as well as financially. And then I already touched on understand if there are any gaps in branch service. It'll also help them to understand if customers should be serviced by other branches. If one branch is closer to a customer, maybe they could be serviced from that one instead of another one, if it makes sense. And then a stretch goal of ours was to predict future revenue in a new branch, and there was some built-in tools with SAP that we could have used, but we unfortunately didn't get to that. So that would be something to look forward into in the future with this project. And our schedule, this was our what we planned to do from the start of the project to the midterm. So in Sprint 1, we were going to research SAP and Here Maps just to become familiar with the environments, because we were very green when it came to SAP. We didn't really know a lot about it. And then we were planning to set up our environment and import all the branch data that our sponsor had for us. And then in Sprint 2, we were actually going to plot the branch data on our map client and then associate that branch data with the markers, so that when you click on a marker, you're shown all the data related to that branch. And you can see down below, we had planned 3 out of our 7 user stories for Sprint 1 and 2, just because we knew there would be some lag with the research part of it. And our schedule from midterm to delivery, we planned on designing our UI in Sprint 3, importing the customer data, plotting the customers on the map, and associating the customer data with the markers, just like we did with the branch data, same process. And then finally in Sprint 4, we were going to implement our sales analysis tool, which allows the user to draw a parameter polygon on the map and then aggregate the data within the polygon to show any data related to the markers within that polygon, which we'll show you later. And then the remaining 4 of the 7 user stories were in Sprint 3 and Sprint 4. So progress, here's what actually happened. As you can see, Sprint 1, we got started very slowly. A lot of the research took longer than we thought, and there was an issue we had with granting certain privileges in SAP, which set us back about a week. So the only thing we accomplished in Sprint 1 was the research part of it. Sprint 2, we were able to finally set up our environment and start developing. We imported our branch data, we plotted the branches on the map, and we associated the branch data with the markers in Sprint 2. And then we even were able to get like a rough layout of our UI in Sprint 2. So we ended up meeting our goal for the midterm, which was great. And then finally, after the midterm, here's what happened. Sprint 3, we were able to get all the data with the customers, map them, and associate that data. And then we realized that we needed to update our UI in order to display sales data for the customers. So we made sure we did that. And then we did some research on a heat map, which is one of the cool things about here maps is you can actually implement a heat map to show concentration of sales data in certain areas. And we researched that, and we realized that wasn't really going to be something that would be visually pleasing for us, because in order to do that, certain customers had to have a lot of sales in regard to another one, and we weren't able to get actual sales data, so we had to randomly generate that stuff. So they were all kind of in the same area, so it really wouldn't have made much sense to have a heat map. But and then we also were able to finally set up our Git repository in Sprint 3, which we were accessing and manipulating the code all on the server, which was fine, but we really wanted some version control. And then finally in Sprint 4, there was a couple extra features that we decided to implement. One being Jesse had a backend mapping site that allowed us to see which locations in the database were actually mapped by here maps and which we needed to use other means of mapping for. So that was really cool, and he'll show you that. Christian implemented a color gradient with the customers where certain markers will show up lighter green or darker green with regards to how much sales that customer has. And then we were finally able to implement our sales tool with the polygons, and then actually add some filtering, so you can filter by state, by top 100 customers, top 50 customers, whatever you want. And then finally updated our UI to show those changes. So Jesse will have a demo here. Give us a moment.
Maybe let's go with the panel.
Sure. Whatever you
All right, so the first thing here, this wasn't necessarily planned from the start, but after some experimentation with geocoder and whatnot, it ended up being somewhat necessary. So when you first load this up, this is intended to be like a back-end panel, not for necessarily a front-end user. And the left side here shows you just information on the data. You click that scan button and it'll go through all of the customer data in the HANA tables and figure out which ones are mapped already, which ones still need to be mapped with the geocoder. And then it'll also ping the Here Maps API and the Google Maps API to tell you if your daily quota is used up, because there's a daily limit on how many calls you can make to each API. And Chrome gets a little upset with it running too slow, so it thinks it's unresponsive. But as soon as it comes up here, it'll show numbers in the map locations, non-map locations, and then it'll give you a yes or a no for the used up columns there.
We can go ahead and skip this and just
And then this right side over here, when you click this start button, it'll start going through each of the locations in the HANA tables and try to map them based on, okay, there, the left side just filled now. So you can see we have 1,126 of them mapped, and then there's still like 19,000 left to be mapped. And but on this right side, this slider right here controls the margin of error, basically, for the geocoder, because when you put in a text address, it can't necessarily associate that directly with like a point on a map. So you have to give it a margin of error for how it can find the lat and long for each address you throw it. And the Here Maps API has a lot of inconsistencies. So when we run through here, it'll start sweeping through, and it'll first try to use the Here Maps API, and if this checkbox is checked here, it'll then backfill with the Google API if it doesn't meet the relevance. And she's going a little slow again, so nothing started yet. But I'll just have you trust me that it works, and we'll just go over to the other side. Okay, and then here with our map, when you first load in here, alright, just give it a second here. Alright, there we go. First load in, the map would just be clear, centered on the US. You have two checkboxes here. You can check to show the branches, check to show customers, and then if you scroll over to the side here, by default it just has a global filter, so it just looks for any locations, and then it's set to display the top 50. I'll take the branches off so you can see them a little better. And so let's say you were to want to see 500 instead. You just throw an extra 0 on there, apply it, and it'll fill in 500 of the top ones now. Or if you wanted to go by a state and say you want to see 50 of them from Minnesota, you can apply that, and then shows you your top 50 in Minnesota. And when clicking on one, it'll show you all the basic location information in the table there, and then it also graphs out the sales data from the last 3 years here. And then the coolest new tool we've got is this data aggregation tool here. So if you check this box and then start clicking on the map, you'll draw a perimeter, and anything inside the perimeter that's currently displayed will then populate here. Well, the top 10 will show here, and then it'll show you your total down here. And if you uncheck this, you can just run back over to this page and say you want to see, like, well, this one looked pretty good in there. You can go look at all your sales data there. And that's more or less it for her.
So we obviously ran into a few issues throughout the course of development. I'll talk about those a little bit. All right, so first off, Austin touched on a little bit that no one had any experience with SAP, or really any of the tools except for like JavaScript and CSS that we were using throughout the course of development. So we had to familiarize ourselves with that. It was a little bit difficult because SAP uses some different syntax than is typically used in JavaScript libraries, so that was kind of something to wrap your head around, so that you knew that you, well, weren't going to mess up any of the tools that they provided to you. And then one of the sillier things that we experienced, which is why the research took so long in the first sprint, was that there are a bunch of users rather that SAP has you create at the beginning of development, and then it tells you, okay, now for the rest of development you're going to use the system user, and it just says in all capital letters, system user. And so we kept trying to use the different users that we had created, but it turns out that they literally just wanted us to put in system and then whatever password we had provided to them, which was probably the more embarrassing of any of the issues that we had had. Another issue that we had within SAP, I don't know if you remember, but we didn't get the Git repository working until the third sprint, which is, I mean, that should have been done in the first or second sprint. That's just kind of a situation where we're not 100% clear if it was just because of the trial, but there are 3 different places that I ran into that you can make a repository in SAP, and we ended up like trying different ones when it says we can't find your project, or we tried a different one and it just doesn't load anything to show us that we can load our files. But turns out we had to synchronize one individual location with GitHub at a time, and then give it a very long amount of time before it says no data to show all of the files that we have, and then we're able to push it out to GitHub. It takes a while unless you really minimize the location that you're looking at. One of the bigger issues we also had was with here maps inaccuracies. Here maps is based out of Europe, and so it seems like they're just not, their coordinates aren't as tight with places in North America. And so if we give them a place like in Arizona, occasionally it will give us back a place that's in Arkansas or something like that, because that's what the relevance rate takes care of. And that's why we ended up having to backfill with Google Maps APIs. And the reason we can't just use Google Maps flat out is because it's going to be more expensive. But we may or may not have a few trials running for everything at the moment. And the reason is because either they are time-limited trials, or with the Google Maps you can only do so many in a day, and it would be it wouldn't work out so great if we had to be like, oh, let's cut off development with Google Maps for the day because we ran out of our quota. So we had to make a few of those. Postmortem summary. One of the things that we learned throughout the course of development is that it's a good idea to communicate often with the customer so that you don't get too deep into development with something that doesn't matter that much. We spent a lot of time on trying to figure out the inaccurate markers, like as an entire team, because we thought that was pretty much, if we can't figure that out, then that's just going to be an issue that is insurmountable and the whole project is not going to be worth anything. But then when we actually brought it to our sponsor Alex, he said, just leave that alone for right now, we can figure that out later. I'd rather that you get some other things figured out. It's also helpful to figure out the requirements immediately, and then because they were kind of unclear at the beginning, but we got them sorted out, and then progress went quite a bit smoother after that. Documenting early and often is also something that we learned was a good idea, because when we pass this over, we have user manuals that the user will be able to use, and developer manuals that the person who's going to be taking over development is going to use in order to fill out everything in their own system. And if you get behind on that, it's kind of difficult sometimes to remember, like, where were we and in what order did we do all these different development things, especially with SQL statements, because some of those are time sensitive in development. Also researching proactively. So if you're caught up on anything and only one person is looking into what the problem is, that doesn't mean that you can't be looking into the future at, like, well, we have some inaccurate map locations, so we can have another person look at the sales analysis portion, withdrawing the perimeter, while one person is focusing on this. And then, you can kind of just branch out and accomplish a lot more things in the same amount of time. It's also we learned it was very helpful to discuss roadblocks in person, because pretty much every time that we had an issue that was a persistent issue, if we just met up together as a group and we talked about it for a little bit, this would often happen like after our sponsor meetings or during classes that we didn't have normal scheduled class time, we would be able to figure out our issue within 30 minutes or an hour just by taking everyone's little piece of information and putting it all together, and then everyone can work through the problem that way together. So the next steps that are remaining for the project would include border states taking all of our code and following the developer manuals that I mentioned earlier, and then getting it imported into their system. They can just use the GitHub to take in the code, but then the specific steps and order of everything is going to be in the developer manual. And that's because we weren't actually able to get access to their internal, for security reasons, we weren't able to get access to their internal SAP system. Another thing, this was a stretch goal, but we didn't get to predictive analytics. It's also not clear exactly how helpful that's going to be, depending on how much data they have, just because basically it could tell you, well, you have a lot of sales here, so you can put in another branch, and then it's going to make more money naturally, right? Well, that's how a computer thinks, but that is not necessarily exactly how it's going to work. And then another thing could either be reformatting the addresses, or using Google Maps, or just keeping the relevance rate extremely high and then slowly feeding in addresses from Google Maps, because it's quite a bit more accurate than Here Maps is. That's pretty much everything that's left for development, and that is all we have. Does anyone have any questions?
There was talk about color gradients not being used, but
yeah.
Heat map being used.
It's the other way around, actually. So.
Or, I'm sorry. Yeah.
Yeah.
Did I miss seeing that? Or did you
It might have just not been so apparent on the screen.
Point that out.
Yeah.
Yeah, if you just move it up to like 1,000.
location, so it'll be more obvious.
Okay.
And filter doll.
I think that worked. Yeah. And this is actually another issue, I would say, is we had to end up, instead of calling to the mapping API every single time, we ended up storing the latitude and longitude within the tables. So here's a good example of like, yeah, oh yeah, these ones are all quite a bit closer, where they just have slightly different tints of green, and it's just dynamic to whatever's the lowest sales to whatever's the highest sales that can possibly be had. And it's just a little bit more apparent if we do it this way than if, and I can tell you're having a hard time seeing. Yeah, well, yeah.
But there you can see the one over yonder is dark green.
I'll promise it's a little bit more apparent on this screen.
Yeah. So this is just another way that we found to distinguish between, at a glance, like which one has more sales, which one doesn't, than the heat map. The heat map really didn't show much. So.
Yeah. Because it's just so concentrated, it's over the whole map, whereas now it's just concentrated points.
Yeah.
I guess the only other one, I like what you're doing.
Okay.
The Google pricing,
Yeah.
thing that you discussed that with them, do you know what they're planning to do?
We actually, this is all kind of happening recently where we figured out the panel and everything. And so we just kind of, well, Jesse had kind of jammed it in and then got it working before, just to, like as a proof of concept even. So we don't actually know exactly how they're going to move forward with it. Any other questions?
Thank you.
Okay, awesome. Thank you.
Disconnect.
All right, I'm Barrett Davis.
I'm Cody Coons.
I'm Jordan Rothstein.
And I'm Ayushi, and this semester we worked with Meridian Mutual Insurance for our capstone project. So brief outline of our presentation, we'll go over the company overview, their history, the problem that they want us to solve, and the solution that we provided them, the schedule that we followed, and the progress that we've made so far this semester. And then we'll also go over the risks and issues that we've had throughout this semester, as well as looking back and summarizing what we've done and the next steps for Meridian to take. So first off, we're going to go back and forth between Meridian and Blue Cross Blue Shield, because Blue Cross Blue Shield is the parent company for Meridian Mutual Insurance, and it merged in the 1940s after the Great Depression for North Dakotans. And it really helped them out to the point where the enrollment had skyrocketed by the 50s and 60s, and so, which is why in the 60s they finally got their first computer to manage all their employees and customers. And so, moving to 2018, their problem is that they would like to have a patient perspective on respective treatments for once they file a claim, and they want, with this result that they gather after like 30 days when the claim is filed, they'll use the information to find treatments, find patterns among the treatments, and reimburse successful doctors. And so our solution is building a mobile app for Meridian that will send out surveys to patients based on their claim number that they have processed. And these surveys will be then recorded into a secure database that will then be pulled out, and the information will be pulled out to make nice little reports to find patterns and for Meridian to do their work. And so with that, I'll hand it off to Cody, who will go over the design for the app.
All right, so this is a diagram of the pages we decided to create. Our first one over here is the first page you will see when you pull up the app. It has a username and password that you enter in that goes to an account database. Then we have the create account, which leads to this page over here, which you enter in your username, password, and then you confirm your password. And when you hit register, that also puts that account into our account database. When you hit the login page, that takes you to this one over here, which is a page that has all the surveys that are available to be taken by the patients. Those surveys are in our claims database, which user will file the claim, that claim number, after a certain amount of days after it's processed. We'll eventually send a notification to the app, which will pull up the survey to be available to be taken. Once you click on that survey, it'll take you to this page over here, which will pull up a survey based on the diagnosis code. Each diagnosis code is unique, so it'd be like if you had a cold, a broken arm, broken leg, each one would have its own unique survey that would pull up, and they would go ahead and fill that out. You have buttons here so you can either save if you didn't have time to finish it, so you wanted to come back to it later. You can either hit back, and that would save your current progress as is, and it would take you back to this page over here where it has all the surveys. And then you can hit submit, and that will pull up a notification, notify you that whether it was successfully submitted to the database where it has all the answers and all the survey answers, where it collects them all and everything. This is a diagram showing the architecture, the 3-tier architecture that was originally planned that we were going to base everything on. We have on the top right over there where our app would be in our admin page. Then in the middle is where our app API would actually be, which is what would be used to communicate with the database and servers at Noridian, where it would store all the info. But this way it would increase security so that you wouldn't just be able to straight access the database and servers and all the info in them straight from the app. It'd have to go through things to get there. The hypervisor is there to, it's a software that creates and supervises virtual machines so that you can run all this on the servers. And then next will be Barrett talking about our schedule.
All right, so first up, I'm going to go through our semester so far. So our first step, a couple weeks into January, we met with our mentor, Chris Speaker. We met him at Noridian. He gave us a tour, introduced us to several of his engineers, which turned out to be very helpful. It was also there that we started to plan our project. We figured out that we wanted to use Xamarin to make it easier for cross-platform development, because we want to do this for Android and iOS. We decided on our version control, which is Subversion, and we really just sorted out the details of our project there. Then over the next few weeks, we actually did some Xamarin tutorials, tried to do more research in mobile development, since none of us had ever done anything like that before. We'd only really done web applications, so this was totally new. And then once we had felt more comfortable with that, we did start coding our app design pages, and we obtained a server from NDSU that we were going to use to load the database on. And this is about where the midterm happened. And so our original plan was to get the database schema from Noridian. That proved difficult because Noridian is a secure company. They obviously can't give us access to their database, so they had to prepare something themselves that we could run on our own server. And that ended up just never happening. So our next plan was to create our own mock database. We were going to use a MySQL server, set up a MySQL database, and we did do that. But unfortunately, we ran into some problems with that, which I'll touch on more later. So at that time, though, we did create a MySQL database, and we created data to populate it. And then once we ran into those issues, which I will talk about again later, we reevaluated our goals with Chris some more, and really just refocused on front-end development of the app, and talked about how we're going to hand the project over and started to prepare for that. And then here's just our weekly schedule. We tried to meet at least 3 times a week. We met every Tuesday with our mentor and discussed our progress for the week, what we got done, what went well, what went bad. Thursdays, we met as a group to work on our weekly reports and to sort out any miscellaneous problems that we had with the code on our own. And then we usually met on the weekends at least once to do some coding together. And I'm going to be tossing it off to Jordan, who will be giving a brief demo of the app.
All right, so here's like a brief preview of the pages of our app. The first page you're greeted with when you open the app is a login page. Just enter your email and the password to log in. From there, there's a create account button. If you do not have an account, you can go click on that. It'll take you to the create login page. You can enter an email and then a password and confirm a password. You'll hit submit. It'll verify that the 2 passwords are correct, and then it should, in theory, create an account. From there, from the login, you log in and you're greeted with this page. It's the main page of the app, basically. It'll list off all the surveys you have to take, stating like the doctor's name, where the doctor's office was, what date it happened on, so you know kind of what survey you're taking and for what treatment you had. And from there, you click on that survey. It'll bring you to a survey where you can put in all the answers, symptoms you had, whether you enjoyed your treatment or not, if you'd like to schedule another visit, and then you can, hit back to go back to the main page, submit to submit your answers, or save to save them for later. And since our emulator has kind of been finicky over the course of the semester, whether it be not loading correctly, taking a long time to load, or just having generic problems, I prepared a video showcasing it off to avoid any of these issues. Sorry, once here you see the icon for the app. Once you open the app, it'll bring you to the login screen. From there you can create your account. You can enter an email and your password, whatever you'd like it to be. Here we just have an example of John Johnson, whose password is password. And right here, he submits, but he doesn't confirm his password, so it gives him an error saying the passwords do not match. Here he matches his password, and it takes him back to the login screen once he submits his account. There he can enter his email, and then his password, which for the first time it entered incorrectly, forgot the D at the end of it, so he'll submit that, but it's not the correct password, so it'll throw a red error. He'll correct it, and it'll bring him to this page, where he can select this survey that's for him. And on the survey, there's a bunch of questions and answers. He can select them. Yes or no answers, check boxes for him to check off. And then once he's done, he'll hit submit. And right now that doesn't really do anything since we're not hooked up to a database at all. It's just kind of showcasing that our app does have these basic functionalities, and once there's a database to connect it to, it should be simple to implement all the functionalities needed. And now I will hand it off to Barrett again, who will give you the risks we faced.
All right. I just decided to take a couple of our most important risks and issues that'll be on the next slide. So our first one is that Noridian, being a secure healthcare company, security is very important for them. They don't want to leak any of their patient information, HIPAA. So we wanted to make sure that the app is up to their standards. Part of that includes encrypting the data. And unfortunately, again, we just don't have access to a lot of Noridian's resources. So we talked with them, and they decided that they will do their own encryption on the data. And we just shouldn't worry about that for now. And then our next one is that the app side API coding might not match up with the Noridian database schema. Like I mentioned earlier, we aren't actually connected to our database right now. So right now our variables are more or less guessing what their database schema is going to look like. So it's going to be more extra work for them when we do pass it over, because we don't know exactly how their tables look. So we're just going to comment our code and do our best to make it really obvious what we're doing. And then for our issues, this is the big one. This is the one that's kind of been haunting us this whole semester. We can't actually connect our database to Visual Studio. Like I said earlier, we weren't actually able to get the database schema from Noridian, so we had to create our own database. And when we did that, we created a MySQL database, which we found out later doesn't play nicely with Visual Studio. While we were able to create databases on our server and we were able to populate them, we couldn't actually connect it to our Visual Studio project without creating a complicated API for that. So again, when we reevaluated our project a few weeks ago, Chris, our mentor, said, just don't worry about that. They will worry about that themselves since they'll be using an Oracle database anyways. It'll be a different format. And then our last issue is with the refocusing of our project, we actually will need Noridian to edit some of that API. So again, we're just going to try to make our code as obvious as possible. Like I said, we're commenting it. We're trying to use good variable names so that when we do pass it over to them, it'll be obvious what they need to change, or hopefully it'll just work out pretty well. And then I'll be passing it on to Cody with our postmortem.
So one of the goals we initially wanted to do when we started the project was at the very end, after a bunch of surveys have been filled out and completed and sent to a database, we wanted to be able to compile a report of all the surveys themselves, so to give you like a quick summary to see what people answered for all their surveys. Unfortunately, we weren't able to reach that point. We just didn't have enough time, and with not being able to fully connect to the databases, it was a little bit of an issue. And then the database issues we had, we weren't able to get the schema like he said, because the security involved with it, the info in there, they can't just give that out to people who aren't necessarily with the company and who don't have authorization to view the info that's in them. It was even hard to just get a mock one from them. We weren't able to even get that because it was hard to, because it was too much like what they actually have there. And then we had a little bit of trouble with Xamarin and our APIs. We had to learn about mobile development in general. None of us had worked on anything like that. Learning the new language in Xamarin was a little difficult. And then also coding an API, which none of us had done before. And then also the databases were more complex than what we were used to. So that took a little work to get going. Last thing was when we were able to take the tour of the company, which was very helpful and informative. We just learned, I guess, how much was going on there and how much you had to go through to get certain things, which was why it was a little hard, along with the rebranding and restructuring going on, for us to get some of the info and resources we needed from BCBS and Noridian. We just learned that they have like lots of teams going on there. We met their IT team, their security, some people from their software development team, their database development team, and how they all worked together and did things there. Next will be Jordan telling you about the next steps for Noridian to take.
So basically, next steps for Noridian, once we hand off our application to them, they'll want to have to create a web API to interface with their app to connect to the database. Once they do this, it's basically just implementing all of these functions we already have the generic functionality of, because right now ours is just basically hard-coded. It's substituting our hard-coded stuff for a dynamic stuff, like a dynamic thing from a database per account basis. Next, they'll have to host the database on their own secure servers, since I'm pretty sure ours on the NDSU servers won't be available forever, and also aren't as secure enough for them to use. And also just to have their app secure enough for their HIPAA standards, be it the login or whatever patient information and doctor information is being displayed to the users. They'll need to make sure that no one will be able to access information they shouldn't be accessing, and also the information that's being displayed is correct information that should be displayed to that specific patient.
We'd like to thank Chris Speaker, who's not with us right now. He is doing Army duty stuff. But he's been super helpful. He met with us every week and has been extremely encouraging of all our ideas. We'd also like to thank Guy Hokinson, the IT guy for our computer science department, and Mike Sanders and Durga Podell from Noridian Mutual Insurance for helping us out with creating and trying to connect databases and trying to figure out what our problem was. And also North Dakota State University for allowing us this opportunity to do our capstone. And so yeah, are there any questions?
I guess since you mentioned that you were using Xamarin, presumably for cross-platform reasons, have you done any testing at all in iOS just to see how much of it worked, or was that something that didn't even really enter in at this point?
So Chris did, initially he did want us to do both cross-platform, but then halfway through the semester he wanted us to focus on Android, which is why we just tested everything on our Android.
Okay.
all of us have Android phones and Microsoft computers, so it wasn't very easy for us to test that.
And there's really no readily available iOS emulators. It seems that any that are ever in production, Apple shuts that down pretty quickly, so we couldn't really find anything like that to test ours on if we were to do it cross-platform.
You were using the emulator. Did you try running it on real phones?
Not yet, but theoretically, if it runs on the emulator, it's running the same file that would be ran on our phone, so it should work on any phone or any Android device if it's working on the Android emulator.
Okay. Thank you.
Thank you.
All right, so we are the Pedigree Technologies team. I'll introduce us all quick. My name's Adam.
I'm Tom.
I'm Bryce.
Kevin?
And our mentors, I don't believe they're here today, but our mentors were Will, Robert, and Josh. So go ahead to the next slide. So first off, of course, a little background for our project. So Pedigree is a IoT company. They have, the project we're working on is they have a lot of different fleet vehicles. As you see up here, they have a ton of different engines out on the field. And basically, what they wanted was a way to troubleshoot and diagnose their engines out in the field. If something were to break down or in the garage or whatever, they needed a way to be able to see anything that's happening within any of their assets and be able to track that and have that data localized somewhere. So their solution is, or the solution they wanted us to implement was a mobile equipment. Well, it's part of their mobile equipment dashboard. It's a mobile diagnostic engine tool. So basically what's going on here is they have these devices already created. They handed us all these to test with our own software, and these devices go into your car in the standard diagnostic port, and what happens is that device reads all the data that's coming out of your car, every single metric you could imagine, such as like gas life, RPM, speed, odometer, the list goes on and on. And so that device reads the data and then it connects to your phone via Bluetooth, and then that's where you can look at your phone and see everything that's going on. So in real time, a driver can, press the gas pedal, see what happens when the RPM goes up. Oh, the oil temperature drops dramatically, or something like that. They can see in real time what's going on within their vehicle. So, the next slide. So yeah, so like I said, that's the proposed solution they wanted from us. They wanted some graphical way to be able to cleanly and easily see what's going on with any aspect of their vehicle. And this is useful for any vehicle as long as it has that diagnostic port. So these are just some mock-ups they handed us. We strayed from this, but that was just like the very general idea they basically wanted. And so from here we'll go into talk about our app specifically and what we made it look like and some features we added.
So as you can see, the old design was more monochromatic. It was just blue and white. Everything was a little bit harder to read. And yeah, that's pretty much it.
This was the old design that was actually handed to us, so we are the second capstone team to actually work on this project. So at the end of the last capstone, this was their final result, and so we've been building off of it and making quite a bit of changes.
So for Sprint 1, we kind of just familiarized ourselves with the Android Studio and the GUI. For Sprint 2, we started to make some real changes to the project and added a menu hamburger button, a switch between graph and gauge view, and started to research the CSV file. And then for Sprint 3, we kind of finished the GUI and then did some more gauge and graph updates, as well as a home screen update. And then for Sprint 4, we finished the gauges and graphs, finished the CSV, did some more bug fixes, and added metrics to the menu.
So for our progress so far, I personally was working on this side menu. Basically, we were trying to replace the current selection menu with a more simple just hamburger menu that would pop out. You can make changes at any time. So I was able to finish just implementing the menu itself. I got the correct metrics to display. I added select all, select none buttons.
and when you select the correct metrics, there's a little slider switch, and I got all of that to work. So,
and this will make more sense when you see our app in a second with the demo. But it's a typical, every app nowadays uses this side menu that Bryce is working on.
Yep.
But carry on.
For the gauges, we finished up the gauges 100%. Everything's implemented, all the user stories and everything that Pedigree wanted has been implemented into the gauges. We have improved the overall look, the readability of it. We've added a bunch of features which we'll cover more in depth once we actually do the demo.
Similar with the graphs, everything's been finished, and it was mostly design and a little bit of functionality change. And yeah, we'll talk more about it later.
Yeah, and one final stretch goal they asked for. So they wanted to be able to export all the session data to a CSV so that they can upload that to their servers and then, do whatever sort of parsing they want, do any sort of trend finding with that. And so I worked on the CSV export. So after your session's done, you're reading all the data, and then when you hit export CSV, everything you've looked at so far is then, quite obviously put into a CSV file format. And once again, we're going to show all this off in the demo in just a moment here. So
let's just do the demo.
All right.
All right. Typically for our demo, we would use an engine simulator, but we're not going to be using that today. We're just going to be using some test data that we have implemented into the app. For our midterm presentation, we used the simulator and we used the dot cam, and it didn't show up very well. So we figured we would just use some test data so we can actually get a clear image of our working app this time.
Right, so like Kevin was saying, right here is where, this just says test device, but if you were within range of a Bluetooth device that you were paired up with, you would have a list of different devices here with all of your paired devices. So because, like he said, we're not using our simulator because it didn't show up on the screen very well last time, we'll just use some test data that just feeds in, just like the same way it would with the actual engine. So, test device, yeah, I'll just go ahead and select all of them. So this is the list, so this is like, not every engine will have all these metrics because I don't know why, just it's what the engine's set up to display. But this is all the possible, if an engine did have everything, it'd be this. So that's everything. We'll go ahead and hit go. Yeah, all right.
And then, so on the front, on this screen, as you can see all the different metrics. We have the engine RPM, we have the diesel level, we have speed and all these other things. And then towards the bottom, if we scroll down,
emulator's a little buggy. It's different on our final.
Come on. We have the text-based metrics near the bottom, and these text-based metrics are things that don't have a max or a min. So the miles you've driven in your car, it doesn't have a max or min. There's no reason to put that in a gauge or a graph. So those are displayed at the bottom. One thing Pedigree wanted, they wanted if we would rotate the screen, it would display 3 gauges. They do increase in size a little bit, which might make it easier to read, but this is what Pedigree wanted. Same thing. These are displayed on the bottom. Just rotate it back. Wrong way. We added a little button up top. This switches from our gauge to the graph. You can also just side swipe, which brings this to the graphs.
I'll real quick point out, Kevin played with a lot of different designs on the gauges, so we tried different coloring schemes, we tried different backgrounds, different ways to define one gauge from another, and I think we're all really pleased with how it turned out because now it's very clear, but it still looks good. It looked kind of cartoony when it was colory, so the clear defined edges are really what make those gauges better than the ones that we were handed off, those blue weird arcs. So go ahead and select your graphs now.
And for the graphs, everything was just made kind of clearer and sharper. We changed it so that each graph is a separate color depending on the metric. Also, some of the Y values were rounded. There was some X value smoothing going on because initially it was a little bit jerky. And yeah, that's pretty much it.
On the original design, they were actually missing the Y values. They only had a max and min, so they actually didn't have any values in between. So like this one, it goes from 0, 30, 60, 90. On theirs, they'd have 0 to like 92 or some random value, and it didn't, it wasn't very helpful having 0 to 92.
And we don't have our old app to show off, but this is incredibly smoother than it was. Before it was extremely jagged, it would update every half second versus, but this is smoothly rolling along, so we did, we're pretty pleased with our work on this as well. with our graphs. So yeah, I can talk about the CSV export now. So like we mentioned before, this hamburger menu, Bryce made. And so when you're done with your session, if you just hit upload CSV, you get a little, exporting CSV message there. And so through Android Studio, it's, in this file structure, I don't need to talk about that. I can click, well, it's already pulled up, I guess. All right. And so there, now it exports via, so each, this is from it would have all the apps. This is from our export from before, which we only have 4 metrics on this one because this is from right before when we exported one. But basically, it's just a data value followed by the time point. And so for our final presentation here, we do have some tweaks to this format that we didn't quite push for the master, just so we didn't break anything. So this is going to be in a slightly different format, but the same data is still there regardless. The same idea is still here. And so it's a huge list, but it's parsable and it has all these different, it does not take long to fill up a lot of data on this file. And so the thing we didn't quite get to because, well, just other things are more important, they were looking to have the CSV file automatically uploaded to their servers. And so we didn't really play around with any sort of security and connection stuff like that. We figured that'd be pretty easy for them to just, add that functionality, which they agreed. We'd rather focus on the design and the looks of it. So, but just for future reference, the stretch goal was to be able to have this exported to their servers directly. Right now, it's just saved on the device itself on the internal storage. But that is a general idea. Do we have anything else to show off on that? Oh, that's right. Yeah, my bad.
So I mostly worked on the slide menu here. The one that's displayed here is not the most recent. I didn't want to push my changes just because not everything's completed and I didn't want anything else to break. But we're able to click this button and we're also able to just slide the menu over. But I have some, let's see. I just took some screenshots here. So the view on the left, that's what I essentially was trying to replace. I was trying to take all of those metrics that you could select and place them inside the menu, totally getting rid of that activity. So just, I guess, starting from the top, working down, I added a basic add preset button. At the moment, it doesn't do a whole lot. I mean, when I select it, it pops up this this keyboard, and then for whatever reason, it adds a preset to the very bottom, which that would be something I would have to work out. And then I would obviously just have the user be able to change the title of that menu item, and then I added the select all button, and that works. When you select it, it just displays everything, and then as with the select none, that just takes away everything. There's a slight bug with this select all for some reason. I think it deals with the gauges. I just came across it last night, so I haven't had a lot of time to look into it. And then there's the delete preset that just deletes the preset that you made. It'll delete the topmost preset. And then there's the actual metric selection. So you can go through and select or deselect any of the metrics. And then since I couldn't figure out a good way to have those just open up in the background, as you're selecting them, I just set it so that when you close the menu, then all of the metrics that you selected will display. So that is the way it currently works. And then Adam showed the download CSV, which works as well.
So basically our general idea with this was you saw during our demo at the beginning of the app, you open it up and you select all your metrics and then you're going, your session started. And so what we wanted to do ideally was, so in that case, you'd have to, if you want to look at different metrics, you'd have to exit out of the app, restart it, reconnect, relook at, select different metrics you want. Our idea was to just be able to make in one menu, not have to go to a different activity, have different metrics, and then also be able to save those in different presets. So if you wanted to for example, if you wanted to only compare RPMs to speed for some reason, well then you just save an RPM and speed preset, you name it whatever you want, and then it's there within the list. So that's basically the idea with this menu. We wanted to keep it into one activity versus restarting the whole app, and that's just for a user flow thing. So that's our goal here.
We had a bunch of issues and risks. Initially, we were all unfamiliar with Android Studio. None of us have really worked with Android Studio before, so there was a huge learning curve there, and that kind of set us back for a little bit. We got to, watch videos, tutorials, figure everything out. We got handed this application that had like 9,000 lines of code. We didn't really understand it. We had to figure that out. We also had environment setup issues. Initially, when we'd set it up, we get a lot of build errors, and a lot of things just kind of went wrong right away. We figured that out. Another thing that kind of set us back, we didn't have the max and mins for the vehicle data. Well, we did, but we didn't actually realize we had it. It was kind of hidden in one of the files in the application. And then so when we met with Pedigree, they kind of informed us about that, and we were able to generate the gauges based off those mins and maxes. We had a Bluetooth during our midterm presentation. This simulator crashed a few times due to a Bluetooth connection error. That was actually, later we discovered that was actually my phone that was causing the issue, because after our midterm presentation, my phone was crashing left and right with various things. And another risk we had was we were a little worried about the CSV export not being completed. Adam did get that finished, so that is no longer an issue for us. And then unable to complete the menu on time. That was another risk we had. We have the menu. The menu's a good chunk of the way done, but it still has a little bit of work, as Bryce has mentioned. And then the issues kind of lead into the risks. CSV is not complete. It's no longer an issue. That's been resolved. And the menu functionality is not completed, which I just talked about.
All right, so some things that went well. We pretty much finished the gauges, the graphs. We made those a lot more readable, a lot smoother, and then we actually managed to get the CSV working. And I believe we have it in the format that Pedigree wanted. Some things that didn't go as well. The menu. The menu is actually typically it's used as like a navigational tool. So adding simple things like buttons and switches were kind of a pain. It seemed like everything required some kind of like roundabout way to get it to work. Even just adding the metrics, it took a long time just to get that transferred over and actually working properly. Also, because the menu is on an activity, and the gauges and the graphs are actually like fragments of that. Everything, like a lot of the changes that I made would touch the graphs and gauges, so I had to fix issues there when they would pop up. And then something that we would have done differently would be like starting the CSV a lot earlier. Didn't really start that until towards the end. I mean, some of it was just some research stuff, but and then more people working on the menu. So the menu was composed of several different parts. There was the presets, the actual metrics themselves. There was the CSV, and it would have been helpful to kind of divide that up a little bit more.
Right, like Bryce mentioned, one of our biggest issues was honestly that menu was way harder than we ever imagined it would be. The reason we assigned it to just one person was because we figured it wouldn't be that big of a deal, but like Bryce said, because it was a navigation menu, there was so many weird workarounds to get it to work, so it took a lot longer to get that functionality there. And it works without the menu. It's just a user flow thing. It's a lot quicker to be able to have those presets and be able to not leave the app. So we figured get the base functionality, get the look and feel done before that stuff, and then we'll move on to that when we can. So that was probably our biggest fallback, but we just didn't really know how hard it was going to be, essentially. So.
And then some things that were learned from doing this project, time management, that's a big one. We're all in a lot of the same classes, taking other classes, trying to finish up our degrees. And, so we had to, set aside time for meetings and set aside time for, actually working on the project. There was, usually at least one thing due every week. So, we had to make sure that we got those in on time, and everybody was, doing their part. And then a big thing for all of us too was actually having some experience with Android and mobile development. We didn't have a lot of experience with Android or just mobile development in general, so that was a big learning experience that we had. And then of course real world experience. We're working with a real company. Turning in, we're working on a project that will potentially be used by real customers, and we're filling out forms and things that would be used. So there's a lot of real world experience there, and I think it's really beneficial. And then recommendations for any future teams. I would say we underestimated quite a few things, so I would say overestimation is maybe a little bit better. I mean, obviously, if you overestimate, then that could be bad. But there were certain things like the menu that we definitely underestimated, and then there was a few things that we also overestimated too. But and then a second thing would be just to start as soon as possible. There was I would say like the first 2 weeks, we didn't really do a lot of actual programming. A lot of it was just learning Android Studio and just setting things up. But it would have been kind of nicer to have actually just jumped into the code, because I know for myself, I didn't actually use a lot of the stuff I learned in some of the tutorials. A lot of what I've learned was actually just from trying and searching on the internet when I came across a problem.
So for potential future upgrades, Pedigree wants a section in the app that you can view error codes that your card gives out. So when you plug in the diagnostic tool, it'll send the error codes to your phone, and you can view those. Additional monitor parameters. So eventually, Pedigree wants to add more parameters to the application. Tablet support was one thing that they mentioned they want in the future. Our app works with some tablets, but some tablets it doesn't work quite so well, and the resolution gets changed drastically. Then everything gets skewed, and it just doesn't look correct. So that could be a thing for the future. And then exporting the CSV by email or sending it to the servers, whichever one Pedigree wants. And then finishing up the remaining tasks for the menu that weren't quite completed.
Yeah, any questions?
So reports wasn't on the last one, but you mentioned that was one of the things that maybe we're supposed to think about at the beginning. Are they not interested in reports anymore?
I'm sorry, what do you mean by reports?
Well, I thought you'd collect a lot of data.
Oh, the CSV report is probably what we were talking about. So that's just like a per session file is what they wanted.
Well, I was thinking they wanted to look at history of the truck.
See, they didn't really mention that.
Multiple times.
But I think that would be possible with the way we're naming our files, the schema and whatnot. I don't know if we ever really talked about that, but if you export it every time, then you do have a history of the session data. No, that's okay. There's just no direct feature for that, but yeah, you could, in theory, do that for sure. Good question. Anybody else? All right. Well, we'd like to give a big thank you to our sponsors. They were super helpful throughout the course of our project. They let us do our own thing, but they also had good feedback for us along the way. We learned a lot through this project with them. Other than that, I have nothing else to say. If you guys have anything else to add, I think we're good. All right. Thank you very much.
Thank you.
All right, so we are the Adventium Caspian capstone project. I'm Jordan Herman.
I'm Samantha Ingersoll.
I'm Tyler Chosas.
And I'm Ben Mohan.
All right. Hit next. All right. So the overview of our project is we're first going to go through our intro, we're going to go through our problem solution, project use, break down the sprints, give you a progress and the status report, do a demo, post-mortem, and go into our questions. So For our capstone project, we were sponsored by Adventium Labs, and our mentor, Tyler Smith, is right over there. And Adventium Labs is a contract-based software developer that has developed multiple technical solutions for a variety of topics, including cybersecurity, systems engineering, and automated reasoning. And then in our situation, we were doing more of a military-based GPS simulator that uses Federation data. Our primary, I already covered that. The next slide. Project stakeholders and ours were ourselves, the team, our mentor, Tyler Smith, and then we also had the project itself, which is the Caspian project. It stands for Common AADL, Simulation, Planning, and Integration Architecture and Node System. So the problem, why do we need Caspian? Caspian serves as a solution to a current issue within military training exercises right now, costing a lot of resources, a lot of downtime to set up. They're large-scale war games for troops, scenarios that they might be facing in a real-time event. One of these, like a typical scenario could be for you're running a large-scale operation with, let's say, 100, 200 troops in the field. You have to mobilize tanks, aircraft, and UAVs and a lot of other pieces that will cost you like a decent amount of money to the military just to mobilize all these aircraft and vehicles. And they also limit you to where you can perform these simulations. So if you want to do something like, let's say, downtown Chicago or in more of an urban environment, you're more limited, as they probably don't want you flying an Apache helicopter over civilian residents, especially at low altitude. So what this does for us is allows us to open up more of an area for what these war games where these war games can happen and what they can cover. So you can reduce the cost by getting rid of all these large-scale equipment and vehicles being utilized and implement it more in a simulation environment or a stationary node control, which is what ours works with, is kind of a combination of the two. It takes Federation data and outputs it to a GPS simulator that then kicks out some visuals for you using physical and simulated data. So the need short term, what they needed from us was a visual display for customers. We had a kind of short time frame for the main view of the project. It was right around midterm. And then display for the Federation test data. The long term is we need to design something that could then be used later to give you more in-depth interface and upgrade to a large-scale module, as well as a user-friendly display and controls. And then it kicks off.
Okay, so we are using Caspian, which it uses a simulation to provide real-time data, so kind of like a mini-map on a video game like Battlefield 4, where it shows helicopters and ground troops and stuff. It provides a flexible, scalable, cost-effective solution for combat training, so it helps get things done. And what we were supposed to do with the project was take the data we were getting and put it onto a map. So the GPS and simulation data came from one part of the project, and we were building the part of the project that was displaying what was being seen. So the project use, it was to visualize the advanced Federation data, so show what was going on. And from that data, users would be able to react and move. So if there's a helicopter flying, you'd maybe want to avoid it or get out of the way of it. Serves as a future basis or a training map, so you'd be able to pull off maneuvers that you needed to do. And it was allow us for Adventium to show that demo to future customers.
Okay, so I'm going to give you a little bit of a breakdown of our schedule for this entire progress. So we had 4 different sprints. The first 3 sprints were about 2 weeks long each. The 4th sprint was longer because the project was virtually complete after sprint 3. All that was really left after that was project cleanup and some of our stretch goals. So going into sprint 1. During the majority of the sprints, we focused on setting up our workspace environment on our own personal computers. This took a considerable amount of time. We had some issues we kept running into, but our mentor from Eventium, Tyler Smith, was able to help us solve most of the problems that we had encountered. Next, we had focused on displaying dummy information on the open map, just kind of get a feel of how the system works. And we also ended up creating and running a simple federate, just again to get a feel of how all these systems are going to play out. During our second sprint, our main task was to connect OpenMap to the Federation. So after completing that, we worked on viewing a simulated unit on the map. We ran into a couple of difficulties when it came to updating the map in real time. So that task ended up being moved into Sprint 3 after that. And so for Sprint 3, we had carried over that task from Sprint 2, and that ended up becoming our main task in Sprint 3. So really getting the map to display a real-time GPS location on the map proved to be a very difficult challenge. The problem was that even though the simulated point was being shown on the map and the Federation was sending information with the updated coordinates, the map was not refreshing with these given points. So that ended up becoming our largest task by far in this project. It ended up being like 30 story points. So it was a huge task that we really had to work on during Sprint 3. There's a few other small functions that we did during Sprint 3 as well, like the capabilities to zoom and move around the map. These functions were pre-built, but we really just needed to focus and ensure that they were working properly during the sprint. And that brings us to Sprint 4, our final sprint. After Sprint 3, we were pretty much done with the project. Really what remained was to be completed was additional polish and code cleanup. So this included a plethora of small tasks like better commenting, removing unused code like test code or commented out code, and organizing resources in a separate package. During Sprint 4, we also encountered a handful of bugs in the project. So we took some time fixing those bugs. It did take significant time, but we got those all done. And then also during the sprint, we had an option of choosing a stretch goal to complete. Since we had a few weeks extra during the sprint, because it was really pretty much up to us what we wanted to do, we had chose to do display path history. So it's just at each unit now we wanted to decide the unit would display where they had been, and we had gotten that done during ours as a stretch goal in Sprint 4.
So in Sprint 3 with the real-time updating, the main issue with that was OpenMap doesn't really provide a whole lot of documentation, and it's very kind of janky where it is because it's an open source product, and we actually spent a lot of time communicating back and forth with Tyler Smith to get that up and running. I don't even know how many classes and methods we made trying to figure that one out before that one eventually got solved, but that's why it ended up being such a huge ordeal, is the fact that there wasn't a lot of information out there on it. It's hard to find valid data that we could try and apply or rewrite for our project in regards to something that was relatable, as it's very the documentation is very vague when it comes to that open source toolkit.
Yeah, and so basically to sum it up, all the progress that we have made in the past few months, we had successfully connected the map to the Federation, can view units on the map, we can update the movement of the units, each unit outputs its information. There's zooming and panning on the map, and we can now view flight history, and again, view unit information like its altitude. Goals that we did not get to, we didn't quite get to flight path prediction, so that's something that future teams or this project can go towards, is predicting some flight path prediction, and also we can make a more aesthetically pleasing map. As you'll see in our demo, it's very simple, and it could definitely use some updating when it comes to that. So just a couple of project challenges that we had encountered. Communication is one of our biggest things that we had encountered along the way. We have communication sponsor was our sponsor was at times we had just lost a little bit of sense of communication within our team as well. We ended up not having a real clear leader in our team for a little bit of the time. And so after we cleared up all of that communication issues and we actually set someone as our lead, things become a lot more smooth. Another issue we had run into is our accelerated time. Like we stated, most of our project was done during midterm. And so our project had kept accelerating. It changed dates a couple of times. And so that was definitely something we had to work through as that. Our initial project setup took a great more deal of time than we had initially planned, but our Tyler Smith from Eventium had really helped us out in getting through that, and any questions we really had, he was able to help us out with. And then again, the real-time updating of the map was a huge thing that we had to work through, and it being a lot more work than we had initially intended it to be, or had hoped it would be, and we had got it done. It was a lot of work. Some risks that might encounter in the future is we're not really sure if the Federation data could change, and that could alter because the altered source information would require refactor. That's just a possible risk that people could encounter in the future. All right, now Ben is going to take over and with a demonstration piece of our project.
Yeah, so my name is Ben. Currently, our portion of the project was focused on just the basic display of all of the Federation data. So there's not a whole lot of interactivity with the map now. You can move and pan and view the data, but beyond that, that is the bulk of the interactivity right now. So I will show you it in action. So yeah, the display serves as a visual representation of the Federation. And because the bulk of the data is generated, well, all of the data is generated from outside of the map itself, the Federation, you have to start the other federates first. So that's what I'm doing right here. And once all of the external federates are running, it'll start sending data out through the runtime interface. And the map ends up receiving the data from all of the federates that are running. And that includes longitude, latitude, altitude, and the team, along with an ID. And you can see here the units are represented as helicopters right now, and they are stored as unit objects that have all the same data that the Federate passed to them, along with some other additional stuff. We also store previous positions to allow for the history dots. And one of the stretch goals we want to do as well was having an easy way to just display additional variables. And you can see, well, not really, but you can see just adding a label and a variable is pretty simple. And that was one of our stretch goals that we wanted to do. The big challenge that we had mentioned earlier of getting the map to update in real time, it currently runs on a timer and then on a different thread, and it'll just continue to refresh the map, which allows the units to move. So yeah, that was. Oh, and you can see as well that the latitude and longitude, or the latitude, well, it's hard to see, but the latitude does update as the units move. So that was our stretch goal. So we had a post-mortem discussion at the end of our project, and we did an overview of our project and our code, and there was some interesting data. We had 1,100 lines of code roughly, and that was cut down pretty heavily from what we had before. We cut out a lot of unnecessary code and test code and such. We had 12 classes. We had originally only designed 4. So there was 8 more classes than we had planned, and we realized that we probably didn't do as solid a job as planning as we really should have and could have. There's also 103 story points, and that was 9 more than we had planned. And that was tied into getting the map to update in real time. That was a lot more work than we had anticipated. And finally, there was 3 packages, not that big a deal, but then there was 2 months that we spent, another interesting tidbit that we noticed at the end, there was 2 months we spent where The location data, both of the values for the units were getting assigned latitude and not latitude and longitude, so it was just moving slowly through Turkey, which was not what it was supposed to be doing, and we noticed that at the very end instead of at the beginning, but it now moves correctly on the map. But some of the reflection stuff that we have is it's really important to have active communication between group members. Getting a response from, responding to our messages was hard at the beginning. We were not great about it, and that just slowed down everything. Planning in the beginning will make everything easier. We really should have focused more time on creating good documentation and a thorough schedule. We kind of flew by the seat of our pants a little bit for a while, and that definitely impacted how we were able to progress. And without leadership, we didn't really get a whole lot done, and it wasn't like having like a dictator of a leader, but just having someone to organize and coordinate stuff was really important. And then software development is hard, so like doing those things that we could have done, they would have made the whole thing easier and progress faster.
So some of our next steps, we would have liked to implement path prediction, and we had a couple ideas about how to do that, like taking the slope and just adding like a cone out in front. Update more visuals in UI, get some more maps and stuff, and maybe like have terrain on there. We just had the continental world map, and that was okay to work with, but adding more would mean working with some like mapping software, which none of us really had or had experience with. Add for more unit classes, so we would like to add like maybe tanks or airplanes or units for ground troops. And then improve separation, decrease coupling, so split some of our code sections up a little bit more into better classes and stuff. And improve documentation, like OpenMap had some pretty bad documentation, so if somebody needed to edit our code, that we'd have better documentation for them. And any questions?
Is the unit class information there already, so you know whether it's a tank or a helicopter?
At this point, there's no differentiation between the two. So like any unit right now would be displayed as a helicopter at this current point. That could be simply done with a variable addition. The units are a constructor class, so it would just be adding another variable in there to determine which class it gets built, or unit gets built as.
So the information is there, you just haven't.
Yeah, all the necessary output information that it would need to display itself is there. It just needs a new identifying key to change it, which it gets displayed as the map. That was kind of one of the things we were going through when we were designing a lot of our displays, making it very robust so it can be added on and changed in the future to where it's not going to go and just basically blow up the whole project, make you start from scratch, to where it's very buildable and a continuable project for sure.
How hard would it be to replace the map?
The map, depending on what we wanted to, like if we wanted to just throwing a new image on there would be pretty straightforward. But if you wanted to throw something in there that, let's say you have a helicopter going through and you want to be able to change altitude if it's flying over a mountain or over a canyon or something like that, to where its altitude would obviously change. Even if it's flying, just maintaining its current height, once it flew over one of those positions, its altitude would obviously change the map. And that's something that none of us really had. That's one of the main reasons for one of the things we'd like to do, but something we can't really accurately display. I mean, we could obviously just throw a new visual in there and make it look prettier, but it wouldn't have the functionality that you would want from it. Where if you're on the field and you see that you have a mountain ridge to your right and then something's maintaining an altitude of 150, you're going to be expecting it to be coming around a different height over that mountain, but rather it could be coming out at what is considered sea level and be 150 feet above sea level, which might only be 20 feet for that mountain.
Well, really, so as far as changing the map visuals, the thing was just finding better map visuals. It was taking more time than we kind of thought was valuable. There was more polish that we could do rather than changing the map. And as far as like adjusting for altitude and stuff, that was kind of out of the scope of our project. The data is supposed to be funneled in, and there's certainly in the future could be like reactive based on like map information, but as for our part of the project, we didn't alter data as soon as it arrived. So, any other questions?
I guess, was this something, even the current implementation, that it's going to be pushed out and used soon, or is it kind of still early and more of the features that you kind of indicated, like flight path, were going to be integrated in before this is kind of used in terms of training missions? Or
as far as our understanding of the project go, it's kind of like a continuing development process. So this is not like the end product. It's very much like a first iteration. So I don't know if that answers your question. It probably isn't going to be pushed out to like troops as is or something.
Yeah, won't be out there next week. So.
Any other questions?
Okay.
All right, thanks.